Hi, it's Miss Regine, and today we're going to talk about the product rule, the quotient rule, and the power rule. These three rules, if you have them memorized, will help you easily solve many problems in algebra and really be your passport to higher level math because you will see them again in calculus. So let's start with the product rule. The product rule is that if you have numbers that have the same base, so the bases are really your variables right here. Although sometimes if you're doing even more basic math, you may not have variables. So for middle school students, you may just have the numbers raised to a certain power. But if you have the same base and they're the same numbers, then what you can do is you can just add the exponent. So I have x to the first here. If I don't see a number, automatically, if I don't see an exponent, I know it's to the first power. So x to the first and x to the second is x to the third. Now, because let's say this is for a higher level student in algebra, I do have some coefficient here. So you still need to multiply -4 times 3, which is -12. I'm sorry, -4 times 3, which is -12. So the final answer is -12x to the third power. But the rule, the product rule specifically is for your exponents here where you have x to the first and x to the second, and that gives you x to the third. All right, so here's another one. You have x to the second and x to the fourth. You just add your exponent and you have x to the sixth. But you do have coefficients, so we need to multiply 2 times 7, which is 14. Now let's go to the quotient rule. The quotient rule is that if you have fractions and your fractions are division, so you're dividing numbers with exponent, you need to subtract. So here we have 6 minus 2, which is x to the fourth. And over here, so we do have numbers. Like I said, it could be numbers, and this is a combination of numbers and variables. So we have our 6, and they're the same base. So we do 5 minus 3, which is 2, and 7 minus 4, which is 3. Oh, and let me give you one more. One that I want a little variation here. So let's say we have something like this. Okay, so if we have something like this, okay, we have the same bases here. So 5 minus 2, we have 3 to the third. And then we have the same bases here. So we do 3 minus 7, and that is -4. Now, quite often, your teacher or the assignment will say positive exponents, use positive exponent. So if you get an answer where when you do 3 minus 7, the answer is -4, you get a negative exponent, what you need to do is move that term to the denominator. And when you move it to the denominator, it becomes positive. And it's actually the same rule vice versa. If you end up with a negative exponent in the denominator, you can move it to the numerator. And so if you just do the reverse, so remember, inverse operation is how you always get rid of stuff. So if you do the reverse, that will change it to a positive exponent. All right, so finally, we have the power rule. So the power rule is a little bit more involved. So again, if we have multiple parts, but let's really focus on our variable and exponent. This is the second power. It seems confusing. So the power rule means that if you have a power raised to a power, you multiply them. So we have x squared raised to the fourth power. We're going to multiply it, and it's going to be x to the eighth power. Now here, 3 to the fourth power, you would just do 3 to the fourth power, which is 81. So you do actually distribute that power, the outside power, to everything on the inside. So yeah, you'll have 3 to the fourth power. All right, let's see if you have, let's try another one that might be a little bit more challenging. And only by challenging, only because it's a lot of letters actually. So not really. So I have a to the first power raised to the second power. Well, 1 times 2 is 2. So that's a to the second power. B to the fourth power raised to the second power. And that is b to the eighth power. C to the fourth power, oh, well, same thing again. That's going to be c to the 8th power. And the rule would be, let's see if let's try one where it's negative. So you can see. Okay, let's say we have this raised to the negative 3. So we have 2 to the negative 3, and that's going to be 1/8. And then we have x squared to the negative 3, that's going to be negative 6. And y4 to the negative 3, that's going to be negative 12. Now, what I just told you is that you cannot, well, a lot of times they don't want you to have negative in the numerator. So what you would do in this case, and quite often the 1 will suddenly disappear. So I had said 2 to the negative 3 is 1/8, and it is 1/8. But quite often in algebra, we just don't use that 1. I mean, if you use it, it's not wrong. It's just not commonly seen that way. So if you don't see it, oh, but I take that back. This one, you're going to have to keep that 1, because if you get rid of that 1, you won't have anything in your numerator. So I didn't look at that problem closely. So you are going to have to keep that 1 here. So because this is negative, it has to move to the bottom. This is negative 12, it has to move to the bottom. The 8 was already in the denominator. So you need a placeholder 1 in that numerator. But if there was another term up there and it was positive, then quite often they would drop that 1. But if you keep the 1, it's not incorrect. It's just a math formality that we do. So, and these rules can be combined, mix and match. So you'll, as you go through your Algebra 1 and Algebra 2 classes and calculus, they will mix and match these rules where you will have to do them all in one problem. Well, I hope this was helpful. Remember to like and subscribe. Comment below if you have any questions or suggestions for more videos, and I will see you next time. Bye.